Please, if you are active, indicate that you are active. We are currently live now. Good evening, everyone. Please, if you're active, indicate that you're active so we can start. Just indicate your presence so we can start up. If you're active, please indicate that you're active. 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 Good evening, everyone. Please, if you're active, indicate your presence. Indicate that you're active so that we can start. If you're active, please indicate that you're active. If you're active, please indicate that you are active. And let's please share the link to others to join. All right, we are starting quite on time today so that we can finish up Physics 101. This is a revelation class. This is a revelation class. All right, so everything we'll be learning tonight will center within Newton's laws of motion. And from there, I will try and summarize this topic. Then we'll move into something else if there's still time. All right, we shall be looking at Newton's laws. Then we solve some problems regarding Newton's law. We look at collision, the types of collision. Then we also look at coefficient of restitution. Then we look at some problems involving the three types of collision, both elastic, inelastic, and completely inelastic collision. All right. So now the first question we have on our list here says that state Newton's laws of motion. State Newton's laws of motion. Please, if you're online, indicate your presence that you're online. If you're online, indicate your presence that you're online. If you're online, please indicate that you're online. If you're online, please indicate that you're online. We are starting now. So the first question we have, we're looking at a list of questions. I will not be doing my normal way of teaching. Then we'll just be solving problems so that we can just strike the main points. All right. The first question says, state Newton's laws of motion. Every one of you, I believe that you can all state the Newton's laws of motion. Newton's has three fundamental laws. The first law is called the law of inertia. Law of inertia. Second law is called the law of acceleration. Law of acceleration. The third law, I call that the law of, or it's called law of action and reaction. Action and reaction. Now let's look at law of inertia. Inertia, we know that inertia refers to the property acquired by a body to always resist change in the state of rest or in motion. Inertia is defined as a property acquired by a body to always resist change in the state of motion or at rest. That is inertia, or the reluctance of the body to remain at rest while in motion or to keep moving while at rest. That is called inertia. And inertia is that is proportional to what? To mass, meaning that increase in mass of a body tends to lead to increase in what? In inertia of the body. Increase in mass tends to lead to increase in the inertia of the body. So the more the mass of the body, the more the inertia, all right, and the more the reluctance of that body. Okay, so we have seen what inertia represents, and the first law is called the law of inertia. The law of inertia. Now, this law states that every object will continue in their state of rest or of uniform motion in a straight line unless acted upon by an external force. Every object will continue in their state of rest or in their state of uniform motion unless acted upon by an external force. Okay, that's called the first law of inertia, meaning that what is the implication of that law? If I have a body kept on a surface, that this body will remain at rest for years until the force is applied. Until the force is applied, right? Okay, and when the force applied on the body, this force will cause the body to accelerate. The body will cause the body to what? To accelerate. Is that clear? Here we are considering a smooth surface where there is no friction. But if there is a frictional force, it simply means that there will be a force of opposition. Is that clear? Okay, and here we have our frictional force. Then, if you remember when we learned Newton's laws of motion in the previous class, the first class we talked about friction. Is that clear? And friction along horizontal surface, where I was able to connect Newton's and friction together. We say that the sum of all forces here along the x-axis is simply the applied force minus the frictional force, all equals to mass times what? Acceleration. Because if a body is at rest and a force is applied, and that force causes the body to move away from this position, that means the force is doing a positive work, right? But there's a force here that tends to resist the motion, which is called the frictional force. And frictional force is always doing a negative work. It's always subtracting. That's what we have here to be minus Fr. So Fr is always subtracting from the applied force. So the sum of these two forces is equals to what? Ma. So this is the implication of the first law of motion. Second law says is the law of acceleration. The law says that the rate of change of momentum of a body, the rate of change of momentum of a body, the rate of change of momentum of a body is directly proportional to the applied force. What does that mean? That means that the rate of change of momentum of a body is simply mv minus u divided by t, is direct proportional to the what? Applied force, right? Meaning that as this is increasing, the applied force must also increase. Okay, that was what they mean and all that. So from here, we can also rewrite this to be F is proportional to mv minus u divided by t, right? So by the time we take off this sign, here becomes F equals to what? Kmv minus u divided by t. So from here, to define this force, we have to take k to be 1, rather. We have to take k to be 1, meaning k should be unity. K should be unity. Okay? Why do we have to take k to be 1? Because the value of 1 has no effect on the force. So we are assuming that k is equals to 1 to define the force. So if k is equals to 1, that means our force is simply mv minus u divided by what? T. Okay. From the same question we have, then we also ask to prove. The question that says prove that impulse is equals to what? Change in what? Momentum of a body. Prove that impulse equals to change in momentum of a body. From this end here, we can prove that. How do we prove this? I have to cross multiply, meaning F times T. That will give us Ft equals to mv minus u. All right. Impulse is simply the product of force and time, which is also equals to what? Change in what? Momentum of a body. So this is what Newton's second law is actually saying, okay, that our force is equal to mv minus u divided by t. In linear kinematics, acceleration can be defined as change in velocity over t, meaning v minus u divided by t is equals to acceleration. So that means that our force can also be defined as what? Mass times acceleration. So this is also equals to mass times what? Acceleration, where a is equals to what? V minus u over t. The whole of this represents what? A and all that. Okay, that is the second law. The third law is called the law of action and reaction. The law says that to every action, there is always an equal but opposite what? Reaction. To every action, there is always an equal but opposite reaction. Now let's look at the next question we have. Please, if you are following, indicate your presence that you are following. Please, if you are following, if you have not shared that link, share the link now. Share the link, share the link, share the link, share the link, share the link. If you have not shared the link, please do so. Please, is the camera okay now? Someone said if you set the camera. Please, let's share the link. Let's share the link. Are we ready? Now we have seen the first question. I hope this is clear. The first law, second law, and the third law. The third law is action and reaction. Let's say an object with mass A collided with another mass B. How do we apply the law of action and reaction? The force applied from A to B is simply equal to what? Minus what? From B to what? To A. What does that mean is that as this body collided with this, okay, that is the action. The reaction is that this other body will also exert the same force in the reverse direction. As two bodies collided, this body, let's say this object collides with this, okay, both of them will after collision, the action and reaction are equal in the sense that the action created by this body is equal to the reaction. Reaction is always in the opposite direction, so it becomes what? Minus. So if I have force AB, and the reaction will be what? Force BA, because it is a reaction, meaning in the opposite what? Direction. This minus sign is showing us that the two forces are actually in opposite what? Direction. They are in the opposite direction. As this other body collide this way, this other body must have to exert the reaction in the opposite what? Direction. So this is one of the ways we can represent this. Now the next question says, if you are following, please indicate that you are following. Prove that impulse equals change in momentum of a body. Prove that impulse equals change in momentum of a body. We have already done that before. If you are just coming, please make sure you visit this video. This is the proof here that impulse from the Newton's second law of motion, we have been able to prove that impulse equals what? Change in momentum. Impulse is the product of force and time. Why this is what? Change in momentum. So impulse can be defined in two ways. The product of force and time. Number two, impulse can also be defined as change in momentum of a body. The next question says, write down the equation of coefficient of restitution indicating the meaning of each term. Write down the equation of coefficient of restitution indicating the meaning of each term. Write down the equation of coefficient of restitution indicating the meaning of each term. Okay, let's look at this first. What is coefficient of restitution? Some of you must have seen my video, a short video I did, about 60 seconds video I did on restitution. When you hear the word coefficient of restitution, it tells us the nature of the nature of the collision that occur between two bodies. Collision is actually of three types. Collision is of three types. Let me explain. The first one is called the elastic collision. Please don't forget. Elastic collision. Number two is what we call inelastic what? Collision. I'll be explaining them one after the other. The third one is called completely inelastic collision. Now, when you hear the word elastic collision, in elastic collision, okay, momentum and energy are conserved. Momentum and energy are what conserved. Meaning, when two bodies collide together, their momentum before collision is the same as momentum after collision. What is momentum? Momentum is still the product of mass times what? Velocity. Meaning the product of their mass and their velocity before collision is the same as after collision. A good example of elastic collision is the collision of gas molecule. We are told that gas molecules are perfectly what? Elastic. Meaning that in a closed system, when gas molecules collide together, they also collide with the walls of the container. But the type of collision that exhibits or that occur rather between gas molecules is called what? Elastic collision, because in that collision, momentum and energy is conserved. Meaning momentum is not lost, energy is not lost. As those particles are colliding, there's no loss of energy. So we call such kind of collision what? Elastic collision. And it occurs between what? Gas molecule. Right? An example rather is gas molecule. All right. When you hear the word inelastic collision, In this collision, momentum is also conserved, but small amount of energy is what is lost. Momentum is conserved, but small amount of energy is lost. Okay, a good example of this kind of collision is called car crash. When you see car crash, let's say two cars collided or crashed, such collision that occur is called what? Inelastic collision. Are you there? Now, why do we say momentum is conserved? Because after the car crash, the two bodies tend to bounce back, right, and all that. Meaning that after they collided, they maintain their momentum, but energy is lost. Energy is lost in terms of heat energy, in terms of sound what energy. When two cars collide together, you hear a very sharp sound, boom, meaning that there's a loss of sound what energy. And when you go closer to those two cars and touch them, you will feel the heat. Mean there's also a loss of what? Heat what? Energy. So a good example is what? Car crash, which falls under what? Inelastic what? Collision. Inelastic collision. The third one is called completely inelastic collision. In this collision, momentum is also conserved, but large amount of energy is lost. The amount of kinetic energy that occur in this collision is very large. Is very large compared to what? Inelastic what? Collision. A good example of this is a bullet fired from a gun and embeds, let's say, into the wall. Like when you fire the bullet and the bullet embeds and enters into the wall or into a wooden material and sticks into it, we call such kind of collision what? Completely what? Inelastic what? Collision. Because for the bullet to enter and stick, that means it takes a high amount of energy to do that, right? Compared to what? Inelastic collision. But in this inelastic, when they collide, they will not stick together. There will be a rebound, meaning after they collided, they still move their separate way or they move in the same direction. We call such kind of collision what? Inelastic collision. But when it comes to completely what? Inelastic collision, as the two bodies collide together, they must have to stick what? Together and move in the same what? Direction. We call such kind of collision what? Completely what? Inelastic collision. Now, what then is the implication of this here? How do we connect coefficient of restitution to the types of collision? Now, I've defined this already. If you notice that among these three types, one thing is common among them, and that one thing is that momentum is conserved in these three types of collision. Momentum is conserved. Momentum is not lost. Then number two is that the difference among them is that energy is what? Lost. In elastic, momentum and energy are both conserved. In inelastic, momentum is conserved, but small amount of energy is lost. In completely inelastic collision, momentum is also conserved, but large amount of energy is lost. So that means that under elastic collision, coefficient of restitution E is equals to what? 1. For inelastic collision, the coefficient of restitution is between 0 and what? 0 and what? And 1. It's between 0 and 1. Meaning that 0 is less than 0 is less than E, less than what? 1. Meaning between 0 and 1. Then for completely inelastic collision, this is when E is equal to what? 0. Please don't forget this. You might be asked to state the three types of what? Collision, and also indicate their coefficient of what? Restitution. The value of under elastic, the value of E is what? Is 1. Under inelastic, the value of E is what? Is between 0 and what? And 1. Under this, completely inelastic, coefficient of restitution is what? Is 0. All right? Now, what then is the expression for coefficient of what? Restitution. What then is the expression? What then is the expression? Okay, please take note of this. Let me show us something very important. Let's say we have a body of mass M1 collides with another body of what? Of mass what? M2. Possibly they are moving in the same direction, right? And after collision, they move their separate way. Here we have the same mass M1, the same mass what? M2. Okay? Now, here we have here to be our U1. This is what? U2. This is our V1. This is what? V2. U1 means what? Initial velocity of the first mass. U2 means initial velocity of the second mass. V1 means final velocity of the first mass. V2 means what? Final velocity of the second mass. We are looking at collision. This is before collision. Before collision, we have after what? Collision. I'm just using this as a general concept to explain coefficient of restitution. I'm not saying that in all the collision, this is how it must be. Most of the time, M1 can collide with what? M2 in different directions. Let's say if this is coming this way, all right? Once they collide, they can either move together after collision, right? This is a general concept. But let's define coefficient of restitution. Coefficient of what? Of restitution. E. It is defined as the relative velocity of separation over relative velocity of what? Of approach. Please, if you are active, indicate that you are active. If you are active, please indicate that you are active. If you are active, please indicate that you are active. Please indicate that you are active. Please indicate. Indicate. And if you have not shared this link, please share. If you have not shared, please share it now. Okay. Now let's continue. So we are saying that the value of E represents what? Relative velocity of what? Separation. It means how fast the two bodies are moving close to each other. So are moving apart from each other. Approach means how fast are they moving close to what? To each other. Let me explain this. Look at this. Mass M1 is moving towards what? Mass M2. For mass M1 to actually get to M2, that means that our U1 must be greater than what? U2. So it means that velocity of approach simply means how fast are the two masses moving close to each other. How fast is the first mass moving close to what? To M2. Are you there? So for M2 to move close to M1 and collide with M1 while they were in motion, that means the speed of M1 must be greater than what? The speed of what? M2. So what I'm saying here is that our U1 must be greater than what here? U2. Now, separation means how fast we then separate from each other. We then separate after they must have collided. For them to separate from each other after collision, that means my V2 must be greater than what? V1. V2 must be greater than what here? V1. V1. How fast will M1 approach what? M2. For M1 to approach M2, the speed of M1, which is U1, must exceed what? U2. Now, as the two bodies are now moving together, for them to separate, to be apart, that means that this other mass here the speed of this M2 here must be what? Greater than what? Somebody, V1, for them to move apart from each other. So this other mass must have to exert a greater what? Speed. So we are now saying that V2 must be greater than what? V1. So we call this what? Approach. Approach means M1 is approaching what? M2. Yeah, we call this stage what? Separation. Separation, meaning M2 is separating from what? M1. Or M1 is what? Separating from what? M2. So that means that if U1 is greater than what? U2, what is the relative difference? It simply means U1 minus what? U2. Since U1 is greater than U2, so I can only subtract U2 from what? From U1, right? If I'm saying that V2 is greater than what? V1, so the relative difference will now be what? V2 minus what? V1. Relative velocity of approach is simply U1 minus U2, meaning that mass M1 must have to approach what? Mass M2 with a greater speed. So this is their relative speed, their difference in speed. For them to separate, V2 must be greater than what? V1. And that means what? V2 minus what? V1. And that one we call it what? Relative difference of what? Of separation. So that means the expression for this becomes relative velocity of separation, which is what? V2 minus what? V1 over what? Relative velocity of what? Of approach, which is what? U1 minus what? U2. All of this is equal to what? E, where E represents what? Coefficient of what? Restitution. I hope you are following. Please, if you are following, indicate that you are following. And if you have not shared this link, please share, because I'll be solving some problems in your textbook and all that. Please share. If you have shared the link, say I have shared the link. If you have shared the link, say I have shared the link. If you have shared the link, say I have shared the link. Have you guys shared the link? Please share. It's not by saying active. It's not by saying active. Now we have seen coefficient of restitution is defined as relative velocity of separation over what? Relative velocity of approach. Separation we have seen how fast will the two bodies separate after collision, which is V2 minus V1. For them to separate, the speed of V2 must exceed what? That of V1. And that will give us the relative speed as V2 minus what? V1, which is this. For M1 to ask V1 was U2. So we are saying that the formula says V2 minus what? V1 over what? U1 minus what? U2. Now let's finish up. Let me show us some things. Now take note. Take note. Take note that the value of E is equal to what? V2 minus V1 over what? U1 minus what? U2, which is relative velocity of separation over relative velocity of what? Of approach. Now, for elastic collision, don't forget, for elastic what? Collision. Momentum and energy are conserved. Right? Number two, the coefficients of restitution, E is equals to 1. What does that mean? That E is equals to V2 minus V1 over what? U1 minus what? Minus U2 must be equals to what? 1. When the value of E is equals to 1, that simply shows that the collision is what? Is elastic. Are you there? Now you might be asked to state one major importance of coefficient of restitution. The major importance or major relevance of this E is that it tells us the nature of force of collision that occur between what? Two bodies. We have seen that when E is 1, it's called what? Elastic collision. Number 2, it also tells us the amount of energy that was lost between two bodies after collision. Don't forget that under elastic collision, we say that both energy and momentum are conserved. I mean, there's no energy loss. But under inelastic collision, we say that small amount of energy is lost. So it tells us, the value of it tells us the amount of energy that is lost, the amount of Ke that is lost. Ke means kinetic what? Energy that is being lost. Okay. Now, a good example of elastic collision we have said is a collision of what? Of gas molecule. Please take note of this. Collision of gas molecule. But the major thing I want to emphasize here is actually this. Now, the third one is that momentum under this. If they say momentum is conserved and energy is conserved, that implies that the momentum being conserved is simply momentum before collision. That will give us M1 U1 plus M2 U2 must be equals to what? M1 V1 plus what? M2 what? V2. Okay? All right. If I have a body here and that body colliding, here I have my M1, I have what? My M2, U1 and what? And U2. Then after collision, the two body moves their separate way, V1, V2, M1 and what? And M2. Momentum before collision is simply, momentum means mass times what? Velocity. Momentum means what? Mass times what? Velocity. That means before collision would be M1 times what? U1. Mass times what? Velocity for the first body. For this, plus M2 U2. This is the sum of momentum before collision. Then after collision, which is this, right? Here we have M1 V1 plus M2 what? V2. Okay? Then when they say energy is also conserved, the energy experienced when the body collides is called kinetic energy. And KE, we know, is what? Half what? Half mv squared. So for this, that implies that half m1 u1 squared plus half m2 u2 squared equals to what? Half m1 v1 squared plus half m2 v2 squared. Momentum is conserved before and after they are equal. Energy is also conserved before and after they are equal. The energy we are dealing with is called kinetic energy. That means half m1 u1 squared for this first body plus half m1 u2 squared must equal to what? Half m1 v1 squared plus half m2 v2 squared. This is all I can say about elastic collision. All right, at least for your level. Then when we come to inelastic collision, inelastic collision, we say momentum is conserved, but energy is lost. Momentum is conserved, right? But small amount of energy, small amount of energy of KE is lost. Coefficient of restitution is 0 less than E less than 1, meaning between 0 and what? And 1. Between 0 and 1. Okay? So our value of E is simply 0 less than E less than 1. Meaning it must not be 0, it must not be 1, right? It can be 0.1, 0.2, 0.3, 0.4 to 0.9. But once it is 1, 1 means what? Elastic. 0 means what? Completely what? Inelastic, right? Then a good example is car crash, right? Example, we have what? Car crash. Car crash. When two cars collide together. Now, in all the elastic collision, one thing is common, which is what? Momentum is what? Conserved. Meaning this expression can also go for inelastic collision. M1 U1 plus M2 U2 must be equals to what? M1 V1 plus M2 what? V2. But when it comes to energy being lost, meaning energy before collision is not equal to what? Energy after collision is not equal. Before collision must be greater than what? After collision. To find the loss of energy, that small amount of energy that's been lost, what do? I have to sum up the energy before collision, then get the energy after collision, subtract them. Any value we have to give us the loss of what? Of energy. Please take note. The next one is what? Completely what? Completely inelastic. Completely inelastic collision. Momentum is conserved, but large amount of energy is lost, right? Then the coefficient of restitution is what? Is 0. Is 0. In this case, our E equals to what? 0. Right there? Meaning E equals V2 minus what? V1 over what? U minus what? U2 is equals to what? 0. If the value of E is 0, that means when the body collides together, they both stick together and move with a common what? Velocity. When you see a equation like calculate common velocity during collision, that means that collision is what? Completely what? Inelastic what? Collision. That means when the two bodies collided, they both stick together and move with a common. They move together. Like when you fire the bullet and the bullet enters a block of wood and then embeds into it, it's called completely inelastic. The value of our E is 0. Okay, I've only given a good example is a bullet fired into a block of wood and embedded into it. The same thing here for all the collision rather, momentum must be conserved, right? Meaning M1U1 plus M2U2 equals to what? M1V1 plus M2V2. Then there must be a loss of energy. The same thing. Have momentum before collision. So energy before collision is not equal to energy after collision. So what do? We have to get the energy before collision, get that of after collision, subtract them, and get the loss of energy. So that means that there's a loss of energy in inelastic collision and completely inelastic what? Collision. Now let's solve a problem. The next question we have here. The next question we have says, we are moving very fast. Now we have been able to write down the equation of coefficient of restitution, indicating the meaning of each terms. Okay, let me answer this question proper now. Now we have learned what is coefficient of what? Restitution. So write down the equation for the value of E and indicate the meaning of each terms there. Recall that E is given as what? V2 minus what? V1 over what? U1 minus what? U2. Then it indicates the meaning of each term there. All right, so what do we do first? U1 is what? Initial velocity. Okay, let me just dictate them. U1 means what? Initial velocity of the first mass. U2 means initial velocity of the second mass. V2 means final velocity of the second mass. V1 means what? Initial final velocity of the first what? Of the first mass, right? Then another thing again you have to indicate is V2 minus what? V1, which is what? Relative velocity of separation. Then the next is what? U1 minus what? U2, which is relative velocity of what? Of approach. Don't forget of approach, right? Of approach. Now the next question says, oh, this is very simple. A net force of magnitude 0.6 Newton acts on a body of mass 40 grams initially at rest. Calculate the magnitude of the acceleration. Okay, we can solve it, but let's solve again. Let us attempt this again. Let's attempt this question again. The question says that a net force of magnitude, our force of magnitude 0.6 Newton acts on a body of mass 40 grams. The mass of the body is 40 grams. Initially at rest. To calculate the acceleration. Calculate what? The acceleration. Please, in the comment section, can you quickly solve this for me? If you can solve this just within 1 minute, let me have your answer. Within 1 minute, let me have your answer. Can you solve this for me? Who have gotten the answer already? Have you got? Who have gotten the answer? Anyone? Anyone yet? Okay, let's solve. Now we have to find acceleration. This is very simple. Oh, this is very simple. We're going to use from Newton's second law, right? Of motion. The force is equals to mass times what? Acceleration. So from here, but before we do that, we convert our mass to kilogram. Okay. The unit of mass is in kilogram, so let's convert. 40 divided by what? 1000. This will give us about 0.04, right? Kilogram. 0.04 kilogram. So that means from here, our A becomes force over what? Mass. The force here is, from here, A equals force over mass. Our force is 0.6 divided by our mass is 0.04. So when you divide 0.6 by 0.04, that will give us about 15. So our acceleration is 15 meter per what? Second squared. This is very simple. Next question, please. Next question. Next question. Please, if you are following, indicate that you are following. Okay, next question, next question, next question, next question. Next question says, state the difference between elastic and inelastic collision. We have done that already, right? We have done that already. That's already in your notes. Okay. The next question says that a 4 kilogram ball moving at 8 meters per second collides with a stationary ball of mass 12 kilogram and they stick together. Calculate the final velocity and the KE loss after impact. Okay, this is very simple. Let's solve it together. A 4 kilogram ball moving at 8 meters per second. Okay, this is the 4 kilogram ball. 4 kilogram. The speed is, our U is what? 8 watts meter per second. Is that clear? Collides with a stationary. Stationary means this other mass here is not moving. But the mass of that stationary ball, okay, stationary ball, was given as 12 kilogram. 12. So the speed here is 0 meter per second because it is stationary. It's not moving. Then after impact, they both stuck together. Calculate their final velocity. Okay, I repeat again. A 4 kilogram ball moving at 8 meters per second collides with a stationary ball of mass 12 kilogram and they stuck together. That talks about completely inelastic what? Collision, where the two objects after impact, they both stick together. They stuck together and we also calculate the final velocity and the kinetic energy loss after impact. Now this is very simple. So this is the diagram here. After impact, they both stick together and move with a common what? Velocity. So we also find their velocity afterwards. After impact. This is 4 kilogram. This is what? This is 12 watts kilogram. Look at this now. This other mass here is approaching this. So the momentum before collision, this before collision, this before collision, this is what? After what? After collision. Okay. According to conservation of linear momentum, that says that in a closed or isolated system, right? Momentum of a body before collision must be equal to momentum after collision. We might be asked to state the conservation of linear momentum. Sorry, I will have given us this before now. After the collision types are listed, the next should be how momentum is conserved. There's a principle called conservation of what? Linear what? Momentum. The principle says that in a closed or isolated system where there's no external force or external factor, momentum of a body before collision must be equal to what? That of afterwards collision. Meaning that before collision, we're going to have here to be M1 U1 plus what? M2 U2 must be equal to what? M1 V plus M2 what? V. Okay, I repeat again. Why do we have plus sign here? Because this body is taken as a stationary object. It's not moving. So we have to put our plus sign here. If these two bodies are moving in the same direction, in the same direction, I will still use plus here. But if they are moving in different direction, I'll put what there as minus sign. If mass M1 is moving in different direction with what mass M2, let's say this is coming this way, the other one is coming this way. So there will be their relative momentum will be what? M1 U1 minus M2 what U2. That will be the sum of their momentum before collision. But if the two bodies are moving in the same direction, I will use what? Plus. If the first body is approaching a body which is at rest, I will still use plus because this body is not moving. Is that clear? Okay. Even if I use minus sign, I will still get the same answer. All right. Then after collision, they both stop together, meaning they now move together with a common velocity, which is our V here. But if they move separately after collision, that means this mass here we're giving V1. Here we're giving what? V2. But since they stop together, that implies that our V1 is equals to what? V2 equals to what? V. Meaning the final velocity of the first object and that of our second object, they are the same, which is what? V. So I have to use the general V to represent them. So we have M1 V plus what? M2 what? V. But for this one, we have M1 U1. M1, this is my M1, right? This is our M1. This is what? Our M2. M1 U1 plus M2 what? U2. Is that clear? Equals to what? M1 again. M1 V plus what? M2 what? V. All right? Now let's go. Here will give us what? M1 U1 plus M2 times 0. Why do we say U2 is 0? Because this body is stationary, it's not moving. So there's no speed given to this. Equals to what? Between this, what is common is V. We're going to have here to be M1 plus what? M2. So we are left with what? M1 what? U1 equals to what? V. M1 plus what? M2. 0 times M2 is 0. So the only momentum we have before collision is M1 U1. To find their common velocity, what do? Is to divide both sides by what? M1 Abi plus what? M2. Here we have M1 plus what? M2. Can this go with this? Yes. We are left with what? V is equals to what? M1 U1 divided by what? M1 plus what? M2. Now let's put in our value. Our M1 is 4. 4 times. Our U1 is 8. Divided by what? M1 plus M2. That will give us 4 plus. Our M2 is what? Is 12. I hope this part is clear, right? I hope it's clear. Please, if it's clear, let me know from the comment section. Let me know from the comment section, please. Let me know from the comment section. Okay, so let's finish up. Here we have 4 times 8 is about, I think, 32. 4 plus 12 will give us 16. Divide these two, that will give us 2 meter per second. 2 meter per second. 2 meter per second. Therefore, that implies that our V1 is equals to what? V2 equals to V. Therefore, our V1 is 2 meter per second. Our V2 is also what? 2 meter per second. So please take note of this. V1 is same as what? V2. Now the next question says find the loss of energy. Loss of what? Of energy. Let's find the loss of energy. I will use this momentum expression to find my loss of energy from here. To find the loss of energy. Let's see what we're going to achieve at the end of the day. What then is our loss of energy? What is our loss of energy? Loss of energy is simply KE before collision right? Minus what? KE after what? Collision. For this question, our momentum before collision is just M1 U1. After collision is simply M1, right? Plus what? M2 times common what? Velocity. Is that clear? So what do we do for is to find our KE before collision. KE before collision is simply this, right? And KE is half mv squared. So that means I'll convert this expression now to our KE. That will give us what? Half M1 U1 what? M1 U1 squared. And that will give us half times, let's finish off from here, half times our M1 is 4, right? Our M1 is 4. I've cleaned the board already. Let me verify our M1. Our M1 is 4. Okay, that's 4 times our U1. Our U1 is 8. So we have 8 what here? A squared. So this will give us a squared is 64. So we have KE before becomes 64 times 4. Sorry, excuse me. 64 times 4 divided by 2 to give us 128. Our KE is 128 joule. KE before collision is what? 128 joule. Now the next is to find KE after collision. KE after. KE after what? After collision. After collision, I will use this to find after collision. The formula will be half mv, right? But our mass here is the sum of these two masses. So that will give us what? M1 plus what? M2. Then V squared. V squared. Are you there? From the KE formula, half mv squared. For after collision, the mass we have here is what? The sum of both M1 and what? And M2. Then V squared. So KE after collision will give us half. Our M1 is, I guess it's 4 plus 12. M2 is 12. Then we have based on our common velocity. We say V1 equals to what? V2 equals to V, and we have 2 meters per second. So here we have times 2 what? 2 squared. Let's verify again. Our M1 is 4. Our M2 is 12. Okay, that's correct. So let's go. So here becomes half times 4 plus 2. 4 plus 12 rather will give us what? 16 times 4 times 4. So let's go. We have 4 times 16. Okay. Divided by 2. That will give us about 32. So KE after collision is equal to 32 what? 32 joules. Now what do you notice here? KE before collision, the energy is greater. Before collision, the energy must be greater than what? After what? Collision. After collision. Either must be greater than after what? Collision. Okay, let's finalize. We are asked to find our loss of energy. Loss of what? Of energy, right? Loss of energy. Loss of energy. To find the loss of energy, what do we do? KE before minus KE after. Loss simply means before minus after. Before minus what? After. Before minus after. Okay. What we'll look for, our before is 128, right? Minus after is 32. When you subtract these two, that will give us about 96 joules. So loss of energy is what? 96 joules. So the amount of energy lost during this collision is what? 96 what? Joule. You can see that this energy is very large. Imagine the energy we have here. Before is 128. After, from 128, after is now 32. So you can see the big amount of energy that was lost. It's not even like, let's say, a fraction, or let's say 20 joule or 30 joules. The difference is even clear. Is obvious that this is what? Completely what? Inelastic what? Collision. So once you hear the word that the two bodies after collision they stick together and move with a common velocity, that means that it is called what? Completely inelastic what? Collision. Now the next question, let's solve another question. Please, if you are following, say I'm following. If you are following, please say I'm following. Please, we are not many online. Can we please share the link? Let's share the link. Let's share the link. Let's share the link. It won't take us anything. Just to click on the link and forward to your WhatsApp group. If you have done that, please do that. Indicate in the comment section that you have shared the link. Let's share the link to others to join, please. Okay? Please share, 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 share. Okay. Next question says that a machine gun of mass 20 kilograms fires a bullet of mass 100 grams due south with a velocity of 25 meters per second. What is the recoil velocity of the gun? Okay, let's solve it. This is a very simple question. If you're a jam bite here, please take note of this question and take note of this class. Very important, okay? We are told that a machine gun fires a bullet. A machine gun fires, okay, a machine gun rather, with a mass of machine gun. Let's call machine gun, the machine gun. Let's use M1 to represent the machine gun. Machine gun as M1. The mass is given as 20 kilograms. Fires a bullet of mass 100 grams. Let's use M2 as mass of bullets. We are told is what? 100 grams. So what we do is to convert this to what? To kilogram, right? Mass of the machine gun is already in kilograms, so we'll leave it that way. But that of the gun is in grams, so I'll convert to kilogram, divide by 1,000, right? This will give us about 0.1 kilogram, right? Okay, so let's move. Let's finish up with a velocity of 25 meters per second. So the speed of the bullet is given as 25 meters per watt per second. Then we have to find the recoil velocity of the gun, meaning the velocity of what? Of the gun, recoil in meter per watt per second. Now let me explain that we can now solve. This is very simple. Now listen, we call this explosion. It's a type of collision where a particular body that has many particles exploded. Now when you have a gun, inside the gun we have a bullet, right? Once there's an explosion, the gun will release the bullet. Exactly. Now, once the bullet is being released, there will be a recoil what? Velocity of the gun, meaning that once you shoot a gun, you are splitting that gun into two components. One is the mass being released, the gun being released, sorry, the bullet being released rather, that has a mass, then there's a recoil speed. There must be a backward speed experienced by the person holding what? The gun. All right. So the principle here is that momentum is also conserved in every type of collision, like we just mentioned under explosion. We call it explosion. A body can explode into different particles, and the particles will move in different directions. But one thing is that after explosion, momentum of all those particles must have to remain the same. So the same concept is used here. Is used here where we have a gun, okay, and we have a bullet inside what a gun. When you release the bullet, you are separating the bullet and the gun. So momentum of the bullet must be equal to that of what? Of the gun. Now, momentum of the bullet, recall that according to linear conservation of momentum, according to conservation of linear momentum, momentum of the gun, M1U1 must be equal to what? Momentum of the bullet, M2U2. Mass of the gun, we have to find the recoiled speed of what? Of the bullet, right? We are giving the machine gun, the mass is 20. So you have 20 times U1 equals to our M2, we are told is what? 0.1 times our U2 is 25. Okay, now let's watch. What do we have here? Our U1 then becomes, to find U1, we have to divide both sides by what? By 20, right? By what? By 20. How is 20, right? I will not make mistake. M1 is 20, okay, U1 is, okay, is unknown. M2 is 0.1, while U2 is 25. So that means our U1 must be equals to what? This can cancel, right? Equals to 0.1 times 25 divided by what? By 20. So let's see what we are going to have. 0.1 times 25 is 2.5 divided by 20. Okay, our U1 becomes, this is 2.5 over 20 equals to about 0.125 meter per watt second. So the speed of the recoil speed rather of the gun is 0.125 meter per second. 0.125 meter per second. Please, if you are following, indicate that you are following. If you are following, indicate that you are following the speed of the gun. Now, what do you notice here? Definitely, the speed of the bullet, which is what? U2, must be greater than what? The recoil speed of what? Of the gun. The gun only recoil back, meaning a backward force, okay, that the bullet exerted when the bullet leaves what? The gun. Exactly. So that recoil speed should be less. And we have about 0.125 meter per second. But the speed of the gun must be greater because the gun is moving with a greater speed, which is what? 25 meter per second. So this is the answer to this. Please don't forget, okay? Don't forget the momentum of the bullet must be equal to what? Momentum of what? Of the gun. Momentum of the bullet must be equal to that of what? Of the gun. Okay. Next question. Next question says, a 50 kilogram object traveling with a speed of 12 meters per second due north, okay, hit a stationary object of mass 7 kilograms. If they stick together and move with a common velocity. Find V. Okay, let me repeat again. Let me take off that knot. It's just the same thing. Let me repeat. I think there's a mistake here. A 50-kilogram object traveling with a speed of 12 meters per second hits a stationary object of mass 7 kilograms if they stick together and move with a common velocity. Find their common velocity. This is almost the same thing with the one we solved. So I will not repeat this again. Please, on your own, you can solve this by yourself. We have already solved something similar to this, right? So go through the video and try to solve this. Let me repeat the question again. I repeat again. A 50-kilogram object traveling with a velocity of 12 meters per second hits a stationary object of mass 7 kilograms if they stick together and move with a common what? Velocity. Find their common velocity. Now the next question is, let's solve the next question. A 5.10 kilogram traveling at 1 meter per second. A 5.0 kilogram traveling at 1 meter per second collides with 10 kilogram object initially at rest. Determine the velocity of each object after impact if collision is elastic. If collision is what? Is elastic. Let's solve this problem together. If collision is elastic. I repeat the question again. Sorry. A 5.0 kilogram traveling at 1 meter per second. A 5.0 kilogram traveling at 1 meter per second collides with 10 kilogram objects initially at rest. So I have the first mass here, which is 5 kg, right? The speed we are told is what? 1 meter per what? Second. The speed is 1 meter per second. Traveling, okay, collides with a 10 kilogram object. This is the other object, 10 kilogram, but we are told is what? Is at rest, meaning the speed is what? 0 meter per what? Per second. Is that clear? Okay. Determine the velocity of each object after impact if collision is elastic. Determine the speed of each object after impact if collision is what? Is elastic. Okay. Now we are told that if collision is elastic, we don't know the direction of this other object. The truth is that when it comes to elastic problems like this, we can't tell if the direction is this way or this way. But from our calculations, we can determine the direction. But the major thing I want us to take note is that the first object, okay, move with a speed of what? 1 meter per second. And that object collides with what? With another object of 10 kilograms. Initially at rest. At rest means this body is stationary. It's not moving. It's just there. It's just stationary. So the speed of this body is what? Is 0 meter per what? Second. Now after collision, what happened? We are then asked to find their velocities after collision. What is their velocity after collision? Meaning I'm looking for my V1 and what? And V2. V1 and what? V1 and V2. Okay? So let me get a better marker. V1 and V2. Now let's watch. We are told that collision is what? Is elastic. The way we solve under elastic collision is not the same way we solve for inelastic. Like what we saw in in the first example I gave, we find out that momentum is conserved, then we can be able to find their common what? Velocities and the rest. But when it comes to elastic collision, we say that momentum and energy are what? Conserved. Now, please take note. We are told that our M1 is giving us, sorry, M1 is giving us 5 kilograms, while M2 is giving us 10 watts kilogram. We are giving our U1 to be what? To be 1 meter per watt per second. Now, what do we do here? Momentum before collision. This is before, right? This is what? After collision. The mass here is 5 kilograms. Mass here is what? 10 watts kilogram. So momentum before collision is simply M1. Okay? According to conservation of momentum, we have M1 U1 plus what? M2 what? U2 more equals to what? M1. Here we have V1. Here's what? Our V2. M1 V1 plus M2 what? V2. In this case, V1 and V2 are not the same because the two bodies are not, they do not stick together. The only time when V1 and V2 are the same is if we are dealing with completely what? Inelastic collision, where you will be told that the body after collision, they stick together and move with a common what? Velocity. But in this case, we are told that collision is what? Is elastic. It's elastic. That means both momentum and energy are conserved. So we don't know what happened after collision, but one thing I'm sure is that the two bodies never stick together. So they don't have a common what? Velocity. The only condition for them to have a common velocity is if we have a completely inelastic collision. So take note. So for this, we are correct. Among the three types, there's one thing that's common among them is that momentum is conserved. Meaning before collision equals to what? Momentum after what? Collision. This is the general knowledge, right? Now what do we do? Is to put this value here. Let's go. So let's go. Our M1 is 5. 5 times U1 is giving us 1. Plus M2 is 10. Our U2 is what? Is 0. All equals to M1. M1 is 5. We have 5 V1 plus M2 is 10 V2. Is that clear? So here we have 5 times 1 is 5 equals to what? 10 times 0 is what? 0. So plus 5, that will give us 5, right? Equals to 5 V1 plus what? 10 what? V2. So I can rearrange this to be 5 V1 plus 10 V2, all equals to what? 5. Equation what? 1. What we did first is to use the general expression, which is this, to find the first equation, right? And that gave us this. Now, the second we need to do is that we have to recall. I think I can then clean this up, right? Please take note of this. Sorry, let me just recall something so we can solve. Let me use this space. Recall that we talked about coefficient of what? Restitution, right? Hope this is clear. I hope you guys are following me. Hope they are following. Okay. We talked about that when it comes to elastic collision, that the value of our E represents what? E represents coefficient of what? Coefficient of restitution, Abi. I will say that the value of E is simply what? V2 minus V1 over what? U1 minus what? U2. All equals to what? 1 for elastic collision. I repeat again. Velocity of separation over what? Let's say of what of approach must be equal to what 1. Meaning V2 minus V1 divided by what? U1 minus what? U2 must be equal to what 1 under elastic what? Collision. Don't forget, for those who just join us, make sure you go through this video. We have dealt with this. I can't go back again to explain. But just know that under elastic, V2 minus what? V1 over what? U1 minus what? U2 must be equal to 1. So from here, we can recall that our value of E is what? V2 minus V1 over what? U1 minus what? U2. Or equals to what? 1. Now, let's take up this from here. We have been able to solve using the first word equation, the first condition for all collision. The momentum is what is conserved, right? Which gave us this, right? Then we also say that recall that the value of our E, which is equals to what? V2 minus V1 over what? U1 minus what? U2 must be equals to 1. By the time we cross multiply this is like saying 1 over 1, Abi. When we cross multiply, that will give us that V2 minus what? V1 is equals to what? U1 minus what? U2. Hope you are following. When we cross multiply this times 1 will give us this, right? Good. Then this times 1 will also give us what? This. So that means that V2 minus V1 is equal to, our U1 is 1 meter per second, minus our U2. Our U2 is 0 because the body is stationary, right? The body is stationary, so our U2 is 0. So that means that V2 minus V1 must be equal to what? 1. From here, I can make my V2 to stand alone as the subject of the formula. If I'm to make my V2 to stand alone as a subject, that means my V2 becomes what here? What do we have here? We have 1, right? When you move this minus V1 to the other side, it becomes what? Plus what? Plus V1. So I can call this equation what? Equation 2. Please follow. The only way I can solve for my V1 and V2 is to bring this expression out. Are you there? Another thing we can do is to use the second condition, which is energy before collision and after collision is what? Is the same, Abi. You know, we say that under elastic, momentum and energy are conserved. When the momentum is conserved means before and after collision, they are the same. I can also use that of energy, which is half m1 u1 square plus half m2 u2 square equals to what? Half m1 v1 square plus half m2 v2 square. When you use this is very long. It leads us to what we call quadratic equation, but we will end up having the same answer. Are you there? So please, once you hear the word elastic collision, what should come to your mind is what is this? You can as well try this out. After using this to solve for the first equation, you can use it to solve for the second equation and find your V1 and V2. But I tell you, the process is not funny. You will keep on solving until you get the same answer. So the shortest cut to solve for V1 and V2 is to bring up the concept called coefficient of restitution for elastic collision that says that V2 minus V1 over what? V1 minus what? V2 must be equal to 1. Then when you now cross multiply, that will give us this Abi. Then we now say that our U1 is 1, U2 is 1, 0 because the body is not moving, it's stationary. And that gives us what? This equation here. Then we will now make our V2 to stand in as the subject of the formula. And that gives us 1 plus what? V1. Now what do we do? Please don't attempt this, but you can attempt if you want to attempt the same answer. Anyway, what we do is to put equation what? 2 into equation what? 1. I'm solving this two now simultaneously. We have generated our first equation. This is our second equation. So I'm going to put this equation 2 into equation what? 1 to solve for one of the unknown. Now let's see what we are going to achieve at the end of the day. Let's see. Let's see. So let's repeat equation 1, right? Equation 1 that says what? Yeah, we have 5v1 plus 10v2 all equals to what? All equals to, this is not 5 square. Hope you are aware, this is my v2. Let me take off this. All equals to what? 5. Is that clear? Now, for me to solve this, we're going to put the value here. Let's go. Then we have 5. I'm going to replace my v2 as 1 plus v1. That will give us 5v1 plus what? 10 in brackets. Our v2 is what? Is 1 plus what? v1, right? All equals to what here? 5. Now the next is to expand this. That will give us 5v1 plus 10 times 1 is 10 plus 10 times v1 is 10v1. All equals to what? 5. Now let's collect like terms here. 5v1 plus 5 will give us about 15v1, right? All plus what here? Plus 10 equals to what? 5, right? So that means 15v1 is then equals to what? 5 minus 10. Is that clear? So 15v1 is equals to what? Minus 5. So from here we can solve for v1. v1 becomes minus 5 divided by what? By 15. We divided both sides by 15 to get v1. So here we have 5 here is 1, 5 here is 3. So our answer is what? Minus 1 over 3 meter per second. What does that tell you? That our v1 final speed of the first body is minus, is negative. Means that after collision, it means that the first body rebounds. There's a rebound. It rebounded instead of going this way. You know, this body here, the first body collided with what? A stationary object, right? Instead of the body to keep on going, that means the first body bounced back. There was a kind of a retardation, a rebound. Exactly. That was the essence what we have was. That was the meaning of this minus sign here. So, but the speed of this body is what? Is 1 over 3 meter per second. The negative sign shows that there is a rebound. A rebound. Are you there? All right. Now we have gotten our speed, our v1. To solve for v2, already we have v2 is equal to 1 plus what? v1. So we can just say put, right? Put v1 equals to what? Minus 1 over 3 in equation what? 2. And what is equation 2 saying? Equation 2 says what? It says that v2 is equals to 1 plus what? v1, right? So that means our v2 will then be 1 plus our v1 is minus 1 over 3. Is that clear? Okay, so let's solve this further. Let's solve this further. So here we're going to have here to be our v2 equals 1 minus 1 over 3. So our v2 becomes, the LCM here we have is what? Is 3. 3 into 1 is 3. 3 times 1 is 3. Minus 3 into 3 is 1. 1 times 1 is what? Is 1. So our v2 becomes, what is 3 minus 1? That will give us 2 over 3 meter per second. Meaning that after the first body collided with the stationary body moved in that same direction. Okay, this is positive. It moves in the direction of motion. Negative sign shows that there is a rebound, meaning the first body moved move backward. Instead of going forward, there is a rebound, a bounce. Now, but for the second body, it moves in that same direction, which shows we're positive. Is that clear? Okay. Now, let's take note. Therefore, we are saying that our V1 is minus 1 over 3 meters per second, and our V2 is 2 over 3 meters per watt second. Please take note of this. Take note of this. Take note of this. Please, if you are following, indicate that you are following. Indicate that you are following. Indicate that you are following. Indicate. Please, I will need your comments. Make sure you comment. Make sure you like the video. Like. Share, like. Let's keep on liking and keep on sharing. Please, if you have not liked the video, please like it. You can't just be online and you are just watching. Like it. All right? So please like the video. Like the video. Okay. Another question I want us to look at. I hope this part is clear. Please, if you are just joining us for the very first time, we have done some class on Newton's law before. We have seen lift and elevator, right? When a lift is moving up with a certain acceleration, and we also find the reaction or the reading on the scale of the lift. Please go through the videos. Those questions that I gave will appear in your exam. This class is exam focused. We are looking at what are the things that you should expect in your exam. So please, if you have not watched all the videos we have made so far, that means you are really lagging behind. Okay? Because I will not be repeating anything. I will just continue from the ones I've not done. Now let's look at this question here we have here. A ball of mass 0.7 kilogram with a velocity 6 meters per second collides elastically. This is still the same question, but it collides what? Elastically. All right? Okay. With a toy coaster of mass 0.82 kilogram with velocity 3 meters per second. Then after collision, the two objects moved in different directions. So calculate the velocity of the object after collision. Okay, let's look at this question. A ball of mass 0.7 kilogram with velocity 6 meters per second collides elastically with a toy coaster of mass 0.82 with a velocity of 3 meters per second. So the first mass is M1, right? M1 is 0.7 kilogram. Our U1 was given at 6 meters per second, right? The toy coaster, the mass, which is M2, is 0.82 kilogram. The speed of the second mass is 3 meters per second. Okay. After collision, the two bodies moved in different directions. Calculate the velocity of the object after collision. But we are told that they collide elastically. Is that not? Now, what we need to do is almost the same thing we have done so far. Momentum before collision, right, equals to what after collision. Let me just draw something here. Okay, we have M1 and we have what? M2. We don't know their direction, if they are moving in the same direction or different direction, right? So what we're going to do is that momentum before collision, but we are told that after collision, they move in different words, in different direction. Maybe possibly one move this way, the other move what? This way. Okay, so let's look at this. We have M1 and what? M2. Here we have V1, we have what? V2. Here we have our U1. Here we have what? Our U2. Is that clear? So momentum. Recall, let us stop there, right? Momentum before collision, which is M1 U1 plus M2 U2, right? Okay. Is equals to M1 V1 plus M2 V2. Now listen, someone might be asking, why are we using plus here? Since we are told that the two body moves in different directions. While solving, you have to use plus. It is after solving, we now know the value. The value of our V1 and V2 will tell us the different direction at which the body is moving. If they are moving separately, or if they are moving separately, we don't know yet if V1 is this way or this way, or if V2 is this way or this way. So I can't just put minus sign here. It is in my calculation. When we get the value of V1, we cannot determine if V1 is rebanded or V2 rebanded. But let's take this again. Before collision, a body of mass 0.7 kilogram with velocity 6 meters per second collides elastically with a toy coaster of mass 0.82 with velocity of 3 meters per second. This question actually has a fault because the toy coaster, we're not told if it is moving in different direction or the same direction with the first mass. Okay, let us assume that they are moving in the same direction. Let me check something first. But for this side must be what? Positive, because it is while we are solving, we can determine the direction of what? Of M1 and what? And M2. Now let's watch. What do we have here? Our M1 is 0.7, right? Times our U1 is 6 plus M2 is what? 0.82 times U2 is 3, right? Equals to what? Our M1, we have M1 as 0.7 V1 plus M2 is 0.82 V2. Is that clear? So let's multiply these values we have. Sorry, excuse me. Let me get the calculator. 0.7 times 6. Here we have 4.2 plus 0.82 times 3. Here we have 2.46 equals 0.7 V1 plus 0.82 V2. Okay? 0.82, 0.7. All right. So 4.2 plus this will give us about 6.66 equals to 7 V1 plus 0.82 V2. So 7 V1 plus 0.82 V2 is equals to 6.66, right? Equation, what is this? Equation 1. Let me check again. Our M1 is 0.7, our U1 is 6. M2 is 0.8, our U2 is 3 meters per second. So let's check. 0.7 multiply with 6 is 4.2. Good. 0.82 multiply with 3 is 2.46. So 2.46 plus 4.2 is 6.60. So we are correct. So here we have M1 is 0.7 V1 plus M2 is 0.82 V2. Now, also, don't forget that because we are told that this is what elastic collision. Also, relative velocity before collision, right? Or after collision, which is our V2 minus V1 must be equal to what? V1 minus what? U2. Is that clear? This is the second condition that shows that the collision is what is elastic. All right. So let's solve further. This will give us our V2 minus V1 is equals to our U1 is 6 minus U2. U2 is 3. So this will give us V2 minus V1 equals to 3. So the next is to make our V2 as the subject of the formula to stand alone. So V2 becomes what here? 3 plus what? V1, equation 2. Is that clear? Now I'll put equation 2 into equation 1. Equation 1 says what? 7V1 plus 0.82 V2 equals to 6.66. Is that clear? Now let's move on. Let's put the value. It will give us 7V1 plus, I'm replacing my V2 with 3 plus V1 in this equation here. So that means it will be 0.82 in bracket. Our V2 is 3 plus V1. Okay. All equals to 6.66. So 7V1 plus, I'm going to expand this now. Let's expand together. Let's expand together. 0.82 times 3 is 2.46 plus 0.82 times V1 is 0.82 V1, all equals to 6.66. Okay, so let's see what we're going to achieve at the end of the day. 7V1 plus 0.82 will give us what? 7. Now we want about 7.82, okay? Then we have 7. 7 plus 0.82 is 7.82 V1 plus 2 points, okay? Yeah, okay, equals to, I'll move this, right, to the other side. Here becomes 6.66 minus 2.46. Okay, so we have 7.82 V1 equals to 6.66 minus 6.66 minus 2.46. This will give us about 4.2. Okay, so our V1 becomes what? 4.2 divided by 7.82. Let's check this out. Divide this result. 4.2 divided by 7.82. This is about 0.537 meter per second. Guys, don't forget I say that the equation itself has a problem because I don't really know. We are not told if the two masses are moving in the same direction from the equation. So I'm going to solve for V2 to verify my answer. If at the end of the day, the value of V1 and V2 are both positive, that means the equation is not that they move in the same direction. Because the question here says, is a type, I think that should be a mistake from the typist, or maybe the mistake from the person that said the equation. It says that a ball of mass 0.7 kilogram with velocity 6 meters per second collides elastically with a toy coaster of mass 0.2 kilogram with a velocity of 3 meters per second. That was the only statement that was made. So we don't know if this collision occur when they are moving in the same direction or different direction. So I will keep on solving. Okay, I'll keep on solving so we can correct this question. Please, if you are following, indicate that you are following. From the comment section, indicate. Indicate that you are following. Okay, someone start to read the questions a little bit slower. Okay, let me read it again. A ball of mass 0.7 kilogram, right, with a velocity of 6 meters per second collides elastically with a toy coaster of mass 0.82 kilogram with velocity 3 meters per second. After collision, the two objects moved in different directions. So calculate their velocity afterwards collision. They move in different directions. Are you there? So let's calculate their velocities after collision. Like I say, the equation is a kind of faulty, is a kind of deceptive in the sense that before collision, we're not told their direction. So we're just assuming that both bodies move in the same direction. Is that clear? That was the reason why I have to put my plus sign here. But we are told that after collision, they move in different directions. That means that by the time we are solving, one of these values here must be positive, while the other one must be what? Negative, because they are moving in different directions. And don't put minus sign here. It is very wrong. If you do that, that's wrong. Okay, this is very wrong because if you are putting minus sign, if I put minus sign here, that means you are forcing the direction of V2 to move in different direction with that of what V1. So you have to allow the calculation tells us what the direction is, if it's to the left or to what? To the right. Is that clear? Okay. So let's look at our V1. So we're going to put V1 equals to what? 0.537 meter per second. Okay, in equation 2, right? In equation 2, that says that V2 is equals to what? 3 plus what? V1. And that will give us 3 plus 0.537. So our V2 will then be, okay, 3.537. Now, are you seeing that the mistake is so obvious that these two bodies, before they collided, they were moving in what? In different what? Direction. Meaning that the first mass is coming this way, the second is coming this way, and after collision, they now move separately. Okay, so that means the right should be that here must be negative, because if after collision the two bodies must move in different directions, that means either V1 or V2 must be negative, right? So that means that the question should be that the two bodies, before they collide, they were moving in different what? Direction, right? So when they collide together, they move they now move again in different directions after collision. So that means before collision, we're going to have M1U1 minus M2U2. So let me correct the equation now. Let me correct it, okay? So in case you made this in the exam, so you know what to do, please take note. This is a mistake from your textbook. This can never be. For example, let me correct the equation again. A ball of mass 0.7 kilogram with velocity 6 meters per second collides elastically with a toy coaster of mass 0.82 with velocity 3 meters per second in different direction. In different what? Direction. Okay, that means they are moving in different direction. After collision, the two objects moved in different directions. After collision, they moved in different directions. So calculate the velocities of the objects after collision. After what? Collision. Are you guys following? So the meaning that here will be minus, right? So M1U1 minus M2U2 should be equals to, so let's resolve this and see what we are going to have in this question. M1U1 minus M2U2 must be equals to this. Like I always say, while you are solving, don't force your minus sign here. It is your value of your speed that will determine the direction at which the two body is moving, right? Okay, so let's recall again. Let's recall again. So we're going to have here to be M1 U1 minus what? M2 U2 equals to what? M1 V1 plus M2 what? V2. Is that clear? So let's go. Here will give us 0.76 times our M1 is 0.7 rather. 0.7 times our U1 is what? Is 6 minus our M2 is 0.82. Okay, minus times our U2 is 2. All equals to M1 is 0.7 V1. All right, 0.7 V1. M2, here we have M2 V2 for 7 V1 plus our M2 is 0.82 V2. Please take note. I'm correcting this now that they are moving in different directions. The same way we solve this, but just that here must be what? Negative. The same thing we just did here. Okay, I will have just said you guys should solve it, but let me solve it to correct the equation itself. All right, so this can occur anytime like this, but when you see this kind of equation in the example, please just make sure that it means that the two bodies must have to move in different directions before collision, right? Okay, so let's start afresh. We have 0.7. 0.7 times 6 is 4.2 minus 0.82 times 2. 0.82 times 2. I'm coming. Let me verify something. Sorry, times 3. The speed of this body is 3, right? Is 3. Okay. Let me repeat again. Our M1 is 0.7. Our U1 is 6 meters per second. Our M2 is 0.82. Our U2 is 3 meters per second. Please don't forget, right? Let's verify again. A ball of mass 0.7 kilogram, the speed is 6 meters per second, collide with a toaster of mass, a toy coaster of mass 0.82. Okay, the velocity there is 3 meters per second. Now let's solve. Here we have 0.82 times 3 will give us about 2.46 equals to 0.7 V1 plus 0.82 V2. Is that clear? So here we have, so this value minus 4.2 minus what we have here will give us 1.74 equals to 0.71 V1 plus 0.82 V2. Therefore, we can say this same as 0.7 V1 plus 0.82 V2 equals to 1.74, equation 1. Also, relative velocity before velocity before separation, right? While V2 minus V1 must be equal to what? Velocity of what? Of approach, which is our U1 minus what? U2. Don't forget that for elastic collision, velocity of what? Of separation, right? Must be equal to what? That of what? Of approach. Separation means what? V2 minus V1. Approach means U1 minus what? U2. Now let's solve. Here we have V2 minus V1 equals to our U1 is 6 minus what? Our U2 is what? Is 3. So this will give us what here? V2 minus V1 equals to what? Equals to 3. So by the time we solve this, we have to make our V2 to stand alone as the subject of the formula, meaning my V2 becomes what? 3 plus what? V1. Equation what here? Equation 2. Now the next is to put the value. The same way we solve for the first one. We are correcting the equation itself. So please pardon me. We are correcting the equation itself. I would have known if the two bodies move in different directions. I just saw the equation in the textbook, then I copied it that way. I didn't analyze before bringing it up. So please pardon me. All right, so let's move on. Now let's put equation what? Put equation what? 2 into equation 1. Meaning I'm replacing this with this, right? And equation 1 says what? It says 0.7 V1 plus 0.82 V2 is equal to 1.74. So this will give us what here? 0.7 V1 plus 0.8. Our V2 is 3 plus V1, right? 3 plus V1 all equals to 1.74. So here we have 0.7 V1 plus, let's expand this, 0.8 times 3. 0.8 times 3 is about 2.4. Here we have 2.4 plus 0.8 times V1 is 0.8 V1 equals 1.74. So let's look at what we're going to do here. These two, they are like terms, we can add them up. That will give us 0.7 plus 0.8. Here we have 1.5 V1, okay, equals to 1.74 minus 2.4. So 1.5 V1 equals 1.7 minus 74 minus 2.4. This is about minus 0.66. So my V1 then becomes minus 0.66 divided by 1.5. Let's see what we have here. Divided by 1.5. This is about V1 equals to minus 0.44 meter per second. So that means that the first mass rebounds, right? There's a rebound after collision because we are told that they both move in different directions. So that means that the direction of V1 is the negative side. This is the rebound speed, right? Now, the next one is to solve for what? V2. We can just put the value. We can say put V1 equals minus 0.44 in equation 2, meaning that says that V2 equals 3 plus what? V1. So our V2 becomes what? 3 plus, what's our V1? Minus 0.44. This will give us our V2 to be 3 minus 0.44. So here we give us our V2 to be equals to what? 2.56 meters per watt second. So that means that the second mass moves in the same direction. It moves, the second mass did not rebound. It moves in the positive direction. Is that clear, somebody? If this is my Cartesian diagram, for example, here we have positive, Abi. This is what? Negative. So the second mass here, the second mass move towards this direction, while this other mass move towards what? This direction. So this move in the direction that is positive, but the first one rebounds after what? Collision. Okay, I hope you guys are following. I hope you 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 are all following. That's the major part. I hope you are all following. Okay, let's solve a problem from your textbook. I hope I can clean this now. We are almost running up with this class. Could you say a force of 20 Newton is applied at an angle of 60 degrees to the horizontal, all right, to the horizontal, to a mass of 4.0 kilogram on a smooth horizontal table. What is the acceleration of the mass? I repeat again, a force of 20 Newton. Let me write out this question. A force of 20 Newton is applied at an angle of 60 degrees to the horizontal, to a mass of 4.0 kilogram on a smooth horizontal table. On a smooth horizontal table. We have to find the acceleration of the mass. Find the acceleration of the mass. Find A. This is very simple. A force of 20 Newton is applied at an angle of 60 degrees to the horizontal to a mass of 4. Then if I have a mass here, the mass is 4 kilogram, right? 4 kilogram. The mass is 4 kilogram. Okay, a force of 20 Newton is applied. At what angle? That means there's a rope here that is used to pull the what? This mass here. Okay, the force, the tensional force on that rope is actually 20 Newton. It's 20 Newton. Or can I say the force applied, on the rope is 20 Newton. A force of 20 Newton is applied at an angle of, so the angle here is what? 60 degrees. It's 60 degrees. Is that clear? It's 60 degrees. On a smooth surface, that means this surface is not a rough surface. That means there is no frictional force. If there's it on the rough surface, it means there must be a frictional force that tends to oppose it, right? But since there's no friction, instead is a smooth surface. I mean, there's no frictional force along the surface of where the body is kept. Okay, this force, don't forget, can be resolved into two components. I've already taught us this. Please go back to the previous class. In resolving this force here, if a body is being dragged with a rope at an angle, okay, this force is dragging this body along both the x-axis and the y-axis. So we have our vertical force here called Fy, then we have our horizontal force here called what? Fx. Okay, so we say that whenever the angle of inclination is along the x-axis, that Fx is equals to what? Fx equals to F cos theta. While Fy is what? Is F sin what? Sin theta. So we are asked to find the acceleration of the mass. Okay, so what we do is that sum of all horizontal force is simply sum of all forces is equals to what? Fx. So that means that the only force doing a work or pulling this body along the x-axis is just Fx. Fx is along the x-axis. But if we have a rough surface, that will be Fx minus what? Fr, where Fr represents frictional force. If I have a rough surface, that means there will be another force here along the x-axis, right? That tends to oppose the motion of the body as this body is being dragged towards this direction. Is that clear, somebody? So why do we say minus Fr? Because any force that moves in against motion or against the direction of acceleration is taken as one negative. Is that clear? Okay, but in this case, we are told that this surface is a smooth surface. So that means there's no frictional force along the path. So the only force responsible for the body to move forward is simply what? Our Fs. So that means I will remove this Fr because we are dealing with a smooth surface. And according to Newton's laws of motion, the sum of these forces is equal to mass times what? Acceleration along the x-axis. But don't forget that we have been able to resolve Fx as F cos theta. Please, if you are not in if you are just joining us for the very first time, go back to my previous class on Newton's laws of motion, of friction rather. I explained this under friction. Please go back, okay? It will really help you to understand more about this. So that means I will say Fx is F cos theta. So we have F cos what? Theta is equals to what? Mass times what? Acceleration along the x-axis. But we are asked to find the what? Acceleration. So that means from here I can divide both sides by mass. By what? By mass. So mass can cancel mass here. We are left with what? Acceleration along the x-axis to be equals to what? F cos theta divided by what? By mass. So to solve for my acceleration, I have to use that formula here. So let's solve. To find the acceleration of the body, we're going to have our acceleration to be equals to our force. The resultant force given is 20. So we have 20 cos. The angle of inclination is 60 divided by the mass of the body is 4. So let's see what we are going to have. Let's see, here we have cos 60. Cos 60 is about 0.5. So I'm going to have here to be acceleration to be 20 times 0.5 divided by 4. Here, 20 times half. 0.5 means half, right? That was 10 over 4. Half of 20 is 10. So by the time we divide 10 by 4, this will give us about 2.5. So our answer here is 2.5 meter per second squared. 2.5 meter per second squared. This is very simple, right? This is very simple. This is very simple. So we are rounding up already because of the power of the phone. But let's see if we can solve more examples. More example. Okay, we have already solved most of these examples in our previous class, so I will not repeat them again, but there's one particular one I'm going to solve. Then we're going to end this class for tonight. Then we'll continue tomorrow. And there'll be class tomorrow at our center. We're having class for all 100 level science students. Please, you can join us to learn. The question says a particle of mass 0.4 kilogram is subjected to two forces. F1 equals 2I minus 4J and F2 equals minus 2.6I plus 5J in Newton. If the particle starts from rest at the origin at t equals 0, find its position and velocity at t equals 1.6 seconds. This is very simple. But let me write out the equation again so that we can take it one after the other. Question says that a particle of mass 0.4. Okay, let me write. A particle of mass 0.4 kilogram is subjected to two forces. Is subjected to two forces. We have F1. F1 is 2I minus 4J, 2I minus 4J, and F2 is minus 2.6I plus 5J, minus 2.6I plus 5J, minus 2.6I plus 5J in Newton. If the particle starts from rest, if the particle starts from rest at the origin or at t equals 0 seconds, find their position and velocity. Find position and velocity at t equals 1.6 seconds. A particle of mass 2 kilogram is subjected to two forces, F1 and F2. If the particle starts from rest, find their position and velocity at t equals 1.6. Now, the first thing we need to do is to find the sum of the two forces. Is simply, sum of the two forces here is simply F1 plus what? F2. If the particle is subjected to two forces, so the resultant force, I have to find the sum of those two forces at which the particle is being subjected to. And that will give us what? 2I minus 4J plus minus 2.6I plus 5J. Is that clear? So the sum of the two forces will then be, I will add up 2I minus 2.6I will give us about minus 0.6I, right? Okay. Then minus 4J plus 5J will give us plus J. Okay. I repeat again. 2I plus minus 2.6 will give us minus 0.6I. Minus 4J plus 5J will give us about J. Is that clear? Now the next is that I want to be sure we are in the right track. Okay. Okay, or we can say 1.0J, right? But let me just use the word J. All right, all in what? Yeah, all in Newton. Don't forget that all the forces are in Newton. Now the next is that we are told that the mass, given the mass, right? We are given that the mass of the body is what? The mass of the body is 0.4 kilogram. Now, if the mass is given and these two forces we are subjected, if I have a mass, okay, the mass is given and a force is subjected to the mass, what do you think will happen? The body will accelerate, right? The body will move from this position towards another position. But we are told that if the particles start from where, meaning that from the initial position, before the force is applied, the particle is actually at the position where s equals was 0 from rest. And from rest, our initial speed is what is 0, right? So that means that if a force, this force here, this is the force subjected to the particle. So if the particle is being applied or subjected by this force, the particle must have to move. We must have to accelerate, right? Must have to accelerate. So what we do is to find the acceleration. We say finding the what? The acceleration of the particle. Recall that will say that force is equal to what? Ma. Is that clear? So that means that sum of all forces is equal to Ma. So from here, to find our acceleration, I will divide both sides by what? By m, by what? By m. So mass can cancel mass here. Therefore, acceleration equals to sum of forces over what? Over m. So that means our acceleration is what? What's our sum of force? Minus 0.6I plus j. The mass is given as what? 0.4. So what we do is to divide. I have to divide this. Let's divide and see what we are going to achieve. Where's the calculator? Okay, I will divide 0.6 by 0.4 and see what we're going to achieve. 0.6 divided by 0.4. This is about minus 1.5I plus, then divide 1. This is 1J. 1J divided by 0.4. 1 divided by 0.4 is about 2.5. Here we have 2.5 J. Okay, so that means that, remember when we learned projectile yesterday, we can represent our acceleration in vector form, right? Which is this. Is that clear? So I can say that recall that acceleration can be represented in vector form because it is a vector quantity, which is AXI plus what? AY what? AYJ. Our AX is minus 1.5. Our AY is what? 2.5. Every vector can be represented in this form. We call this position vector form. Okay, for acceleration, it is what? ASI plus AYJ. So that means our S component of this acceleration is minus 1.5, while the Y component is what? 2.5. Therefore, we can see that our AX is simply minus 1.5 meter per second. Okay, while our AY is about 2.5 meter per watt per second square, rather, per second square. Now, but the question is saying find position and velocity. We have not started. All of this we are just doing is to define the acceleration of the body. So let's find the position. Position simply means that point where the object can be located. Is that clear? Okay. When this force is applied, don't forget the body moves from point 0 to a given point. So let's find the position where the body is. Position, recall that position or displacement is equals to what? Ut plus what? Half what? Half at squared. Half at squared. Exactly. So to find my horizontal position, to find my x position, if I'm to find the position of the body, I have to find both the horizontal and what? The vertical, because we have two acceleration. We have both horizontal and what? And vertical what? Acceleration. So my s becomes x, right? If you are just coming, you have not watched our video yesterday we did on projectile, please go back and watch. That will give you a deep understanding. Find my s position, the s position of this particle. Where can we locate the particle along the s-axis? Is simply by converting this s to be what? X. That means here we then be our uxt plus half ax t squared, right? But we are told that the particle starts from rest. If the particle starts from rest, that means my ux is equals to 0. Even uy is also equals to 0, because at the point where the body starts from rest, we are told that our t is what? Is 0. So that means that if t is 0, that means all the initial speed, both along the x-axis and the y-axis, must be equals to 0. So that means my x here becomes 0 times t, right? Plus half our ax is minus 1.5 times our t. We are told that our t equals to 1.6 seconds. 1.6 all what? All squared. So let's see how we can evaluate this. Sorry, excuse me. Let's evaluate this together. 1.6 squared is 2.56. The times minus 1.5, right? Times 1.5. Here we have 3.82. We square this, multiply with this, then let's divide by 2. Divide the result by 2. We have 1.92. So my x position is simply minus 1.92 meter. Now let's find also y will not be what? For y, what will be here? Here will be uyt plus what? Half ayt squared. To find the y position, because we also have vertical acceleration, we're going to use y. I'll convert this s to the y. So all the speed here, my speed there will not be what? Uy plus half ayt squared. So this will give us what here? Y equals to, our uy is also 0. So we have 0 times t plus half our ay is 2.5. 2.5 times our t squared is still 1.6. Then all squared, right? So let's evaluate together. We have 1.6 is 2.56, right? Times 2.5, that is 6.4, divided by 2. This is 3.2. So our y is 3.2 meter. Okay, then let's find the position vector. We have to find the position. Where can this be located? The position then becomes, we call the position vector is simply r equals si plus what? Yj. Si plus yj. This is called position vector, because I have to represent this in vector form, and that will give us r equals, our x is minus 1.92 meter, so minus 1.92 I plus our y is 3.2 j, all in what? In meter. This is the answer to this first question. This is the answer to this first question. So the second one says find the velocity, right? Find the what? Velocity. Find the velocity. Okay. Okay. And let's find the velocity. The same thing we did. We are almost done. The same thing we did here will be repeated, but in this case, number 2 said find the velocity, right? Velocity. I'll be using my v equals to u plus what? 80. So that means for my vx, since I have as, I have to find vx. Vs will be what? Us plus what? As times t, right? So my vs becomes, our us is going to be 0, right? Our us is 0 plus our as is minus 1.5 times our time is 1.6. So let's multiply this and see what we're going to have at the end of the day. We have 1.6 times 1.5. This is about our Vx is minus 2.4 meter per second. Also, we'll do the same thing for what? Vy, right? Vy is going to be uy plus ayt. Is that clear? Okay. So let's solve. Let's solve. So our Vy will then give us uy is also 0 plus our ay is 2.5 times our t is 1.6. So 2.5 times 1.6, 2.5 times 1.6 is 4. Here we have Vy to be 4 meter per second. Okay, in vector form, right? In vector form, let's represent in vector form. Our V is going to be Vsi plus what? Vyj. Don't forget, velocity is going to be Vsi plus what? Vyj. Our Vx is minus 2.4 I plus our Vy. Our Vy is 4j, all in meter per what? Second. So position and velocity. We have gotten it. This is our velocity. Okay. But what if they say find the resultant position and velocity? If they now say find the resultant, you should know what to do, right? Resultant vector is simply square root of x squared plus what? Y squared, right? For that of velocity, that would be what? Square root of what? Vs squared plus what? Vy squared. If they say find the resultant vector or resultant position and what? Velocity. So after finding this in vector form, we have to find the resultant, meaning here becomes what? Minus 1.92 squared plus 3.2 squared. That's for this. Then for this, I'm going to have minus 2.4 squared plus 4 squared. Then at the end of the day, after finding their resultant, we can now find what? Direction. But the question says find position and velocity. So don't bother yourself going through the process of finding the resultant and the direction. Is that clear? Okay, so how many of you are following? Please, if you are following, please indicate that you are following. If you are still following us, please indicate that you are following. Let's know those who are following. All right, guys. So I'm going to stop here for now. We have exhausted all the questions We have exhausted all the questions. Yesterday we learned about lift and elevator in our previous class under Newton's law of motion. We have talked about inclined plane already. We have talked about frictional force along horizontal surface, along inclined surface. Okay, all of this we have learned. All of this we have learned already under friction. So we have covered friction to some extent. We have covered motion, Newton's laws of motion to some extent. Then my next class will be on rotational dynamics. Rotational dynamics, okay? Our next class is going to be on rotational dynamics. Please, every one of you should not miss this class. Rotational dynamics. Then I will connect this to oscillation, alright? So we'll look at this. Then from there, we'll go into simple harmonic motion and so many of these. Alright, so our class continues tomorrow by this same time. Tomorrow, which is Friday. Then on Saturday, we'll be having a massive class on Saturday at the center. And tomorrow, also being Friday, we're also having a massive class, physics class tomorrow. Please don't miss it. It will be intensive tomorrow. Don't miss any class tomorrow. Physical class, and that class will start by 8 a.m. in the morning. 8 a.m. in the morning to be intensive. So don't miss that class. All right. So see you guys tomorrow. Okay. Thank you so much. If you have any question, you can drop them in the comment section. And if you know if there's any topic you want us to treat that you're having challenge with, also drop those topics in the comment section. Drop them for me. That these are the topics you want us to look at. All right. I will gladly teach on them because I want your growth. I want you guys to learn and pass your exam. Are you there? So please, if you have any question you want to ask, you can always drop them in the comment section. Thank you guys. See you tomorrow in class.